Okay. So real roots can have basically, there are two types of real numbers. Now we split those up into way more types. Like we talked about integers and whole numbers and all that stuff. But really all of those can be split up into two different types. You have rational and irrational. Now what we did yesterday gave us all the possible rational roots. Now rational numbers are like most of the numbers that you deal with. Positive and negatives, any number that can be written as a fraction, so most of them. Decimals, as long as they end, or repeating decimals, like 0.33333, that would be considered a rational number. Irrational numbers are non-ending, non-repeating decimals, like pi, or a lot of square roots, like the square roots that don't come out nice and neat. Square root of 3 is irrational. Square root of 5 is irrational. Square root of 6 is irrational. Only the ones that come out nice and neat. So those are irrational numbers. Everything else is rational, and then if we're talking about real numbers. Then we also have imaginary numbers, we know. So we have this picture and the equation that goes with it, which is h of x. And we're going to talk about three things about this graph. And it says, what three things like you can just magically come up with? But somebody tell me something that they know about this graph that makes sense after you look at the equation.
There's a constant of 9.
Yeah, okay. There's a constant of 9, and that corresponds to, of course, the y-intercept. So yeah, that's definitely something. Something else. Just by, things that we have learned.
Degree is 4 and there's 4 zeros.
Okay. We know that the degree is 4. And so, in this case, there are there's always 4 zeros. They just happen to be actually on the x-axis here. Okay, I'm also going to add to that. They all have a multiplicity of 1 in this case. Oop. Wow, why did I go to 4?
It's even and positive coefficient.
Okay, it's a positive coefficient, which we can tell by looking at it, but we can tell from the picture because what?
They're going upward.
Yeah. So they both point up. So since the degree is even, and the positive and since there's a positive coefficient, they're both going to point up, like he said. And if you wrote point up, that's fine too. Okay, so the next thing says, what conclusion can you draw about the 4 roots of the function h of x? Okay, so think about it in terms of the 4 things we talked about yesterday. Positive, negative, 0, imaginary. So looking at the picture, what do we know?
There's 2 negative and 2 positive.
Yeah. We know that 2 roots are negative and 2 roots are positive. Just by looking at that picture. Okay, so now we're going to find those zeros. We're going to make a list of the possible rational roots using putting your P's over your Q's like we did yesterday. So possible rational roots are plus or minus the 9, the factors of the 9. So what are my factors of 9?
1, 3, 9.
Yep, 1, 3, and 9. Over plus and minus leading coefficient factors. That's a 3. 1 and 3. So we're going to go plus or minus 1 over 1 and 1 over 3. Then 3 over 1 and 3 over 3, which is just 1. 9 over 1 and then 9 over 3, which is just 3. So there's 8 possibles, because remember, all of those can be positive or negative. So from this list, which roots appear to be roots from the graph above?
Positive 3.
Positive 3, okay, I'm going to highlight it. Positive 3. And any others?
Negative 1, 3rd.
Negative 1/3. Oh, I guess I should have written that down. So I'm going to put highly possible rational roots are positive 3 and negative 1/3. So let's divide by one of them. I figured you probably want to pick 3. We're going to divide by the other one as well, but we'll start with 3. The numbers are 3, negative 8, negative 12. I guess I can divide this here. 24 and 9. I bring down the 3. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, then it says, then divide that result by the other factor. So I'm going to do it again. Only now I'm going to put negative 1/3 in the box. And bring down the 3, and think of this as division. 3 goes into 3 once. 1 times negative 1 is negative 1. 0. 0 times anything is 0. Add that, you get negative 9. 3 goes into negative 9 negative 3 times. Negative 3 times negative 1 is positive 3. So it works. So any questions on the synthetic division that we did there? So we took a degree of 4 and we divided it twice. So what's the new degree? Say that again. 2. So it's a quadratic. That's what we need, because we can solve a quadratic. So what you want to do is divide it, if you can, until you get something that's quadratic. And then the roots will be the remaining 2 roots, which in this case are going to be irrational, because I know that the other 2 that are on here don't match any of these 8 that I have. I have negative 3 and negative 1/3, so that one and that one. This one and this one doesn't match any of those numbers. So those two must be irrational. So let's find out what they are. We have 3x squared plus 0x minus 9. I don't really need that 0x, so it's just 3x squared minus 9. And a factor. What can I factor out? 3. That's not a difference of 2 squares, because 3 is not the difference of 2 squares, so that's not going to help. Set each one equal to 0. Well, obviously 3 doesn't equal 0, so I don't have to worry there. X squared minus 3 equals 0. Add 3 to both sides. Now how do I get rid of this?
Teachers, excuse interruption. At this time, the boys' basketball, you are dismissed, going to Clarksville, and girls.
Square root is what we need to do. I meant to ask you, but whatever. So x equals what? Very good. Plus or minus the square root of 3. Because when you do a square root of 3, or when you do the square root, you have to put a plus or minus in the problem. So those are my two irrational answers. And if I looked up here, it's actually like 1.73 something. So it's about, it's right there. And then this one is negative 1.73 something. So it's also close to right there. So it makes sense. It's a good idea to check back at your picture and make sure it works in the problem. So my total roots, there are 4 of them. We had negative 1/3, 3, negative square root of 3, and the square root of 3. Those are my 4 roots, rational and irrational. All the 4 places where it crosses the x-axis. You can figure them out. What do you notice about this graph that does not make sense with the degree?
It's just a problem.
Say that again.
It's just